Welcome back, guys, to our DSA challenge series. In this particular phase of the series, we are looking at the questions which are based on graphs. So let us see our today's question. Our today's question says network delay time. The question is based on Dijkstra's algorithm, and if you have studied the Dijkstra's algorithm, the question is very simple for you. So let me read the question. We are given a network of n nodes which are labeled from 1 to n. We are also given one vector times, which is a list of travel times as directed edges. Times at the index of I denotes ui, vi, wi, which means that there is a directed edge from ui node, that is a source node, to the vi node, that is a target node, and the edge weight is wi. That is wi is the time it takes for a signal to travel from source to target. So you can assume it in this way that UI is the source node, VI is the target node. It means there is an edge connecting UI to VI, and the edge weight is WI. We will send a signal from a given node K. One node is provided to us, that is K, and we are going to send the signal from that particular node. We need to return the minimum time it takes for all the n nodes to receive the signal. If it is impossible for all the n nodes to receive the signal, we are going to return minus. So whenever we heard here the word minimum, we always the thing that strikes to our mind is Dijkstra's algorithm. So we are going to see its application. So first of all, understand this question with the help of an example. We were given times. Times, the first is 2, 1, 1. It means that there is a directed edge from 2 to 1 with an edge weight of 1. 2 to 1, 2 to 1 with an edge weight of 1. 2, 3, 1. Directed edge from 2 to 3 with an edge weight of 1. 2 to 3 with an edge weight of 1. 3, 4, 1. There is a directed edge from 3 to 4 with an edge weight of 1. 3 to 4 with an edge weight of 1. So I hope you all understand how this graph is constructed. N is equals to 4. What does N denotes? N denotes the total number of nodes present in our graph. So there are 4 nodes present in our graph, and it is following one based indexing. One based indexing means that our first node's value is 1, not 0. There are 2 indexing, or 0 based indexing or 1 based indexing. So this particular question is following 1 based indexing. So n equals to 4 means there are nodes from 1, 2, 3, and 4. K is equals to 2. What does K means? K means that it's the source signal. It is clearly mentioned in the question. We will send a signal from a given node K. So we are going to send the signal from node 2. So that is, now we need to return the minimum time it takes to return. So what we are going to do? We are going to make one distance array. In distance array, we are going to store the minimum time it takes for the signal to reach at that particular. So we are starting from k is equals to 2. So distance at the index of 2 will be 0, right? So since we are sending the signal from 2 itself, so to reach 2, we need 0 time. So distance at the index of 2 is 0. Now to reach 1, how much time is required? 1. To reach 3, how much time is required? 1. And to reach 4, what is the shortest path? This is the shortest path. And how much time is required? 2 seconds. So in our distance array, we have time required. We need to return the minimum time it takes to reach to all nodes. Minimum time it takes to reach to all nodes is the equal to the maximum value which is present in our distance array. So our distance at the index of 1, how much time it takes to reach 1? 1 second. How much time it takes to reach 3? 1 second. How much time it takes to reach 2? 2 is the source signal, 0 seconds. How much time it takes to reach 4? 2 seconds. So what is the maximum in our distance array? 2, and we will return that particular value. I hope the question is clear to you all. Whatever I explained you is the same thing I have implemented in the code. So just see the code now. It will give you a better understanding. So what we did, we made a one adjacency list. Why we are storing in the form of pairs? Because we need to store the target node as well as its edge weight. That is why vector pair int comma int adj. Why n plus 1? N plus 1 because it is following one based indexing. Our graph is following one based indexing. That is why the size of our adjacency list will be n plus 1. If it would be following a 0 based indexing, then the size would have been n. I hope you are getting it. After that, we have calculated the size of our times vector, that is int size equals to times dot size. Now in line number 7, 8, 9, we have just made the graph, that is adj at the index of this dot pushback times at the index of I1 times at the index of I1 denotes the target node, times at the index of I2 denotes the edge weight, times at the index of I0 denotes the source node. So in this way, graph will be constructed. After that, we have made one distance array of size n plus 1. N plus 1 I have already explained, just following one based indexing. And initially, we have given it a value as 10 raised to the power 9. 10 raised to the power 9 is a very big value, which means at this particular moment, it is impossible to reach that particular node. So initially, we have defined it 10 raised to the power 9 to each and every index. We have defined a priority queue. Why priority queue? It means min heap we have defined in order to apply Dsachallenge algorithm. But in what happens in min heap? In min heap, the minimum element is present on the top of our stack. The element on the top. The minimum element is present on the top, so we can access the minimum element in the beginning with the help of min. We are pushing 0, k. Why 0, k? The first element in our priority queue denotes the distance. Second element denotes the node. In order to reach, k is our source signal. How much distance is required? Since it is the source signal, the distance required is 0. So that is why we are pushing pq.push 0, k. It means to reach to that node k, we require a distance of 0. We have also updated the distance array, that is DIST, at the index of k is equals to 0. After that, we have applied the while loop, while not equal to pq.empty. We have stored the distance in distance equals to pq.top.first and node pq.top.second. Then we have popped out the element in line number 18. After that, we have made one vector pair in comma int v1. Why pair in comma int? Already told you. It is storing the target node as well as the edge weight. That is why pair int comma int v1. What this v1 will contain? V1 will contain all the adjacent node to our this node which we are accessing. Int node equals to pq.top.second. In v1 vector, we will have all the adjacent nodes to this particular node. We have calculated the size of our v1 vector. We have started the loop for int I equals to 0 less than temp dot size I plus plus. Int new distance. How we have calculated the new distance? Distance value mean. Distance value gives us the distance which is required to reach this particular. Now v1 at the index of I dot second will denote the edge weight. So in order to reach that new node, we require the distance of distance plus v1 at the index of I dot second. Let me explain. If I want to reach this particular node 4 from 2. So in order from 2 to 3, the distance is 1. Now in 3, suppose we are on 3. So 3 will contain the value 4. So in order to reach 3, we have already required a distance 1, which is stored in this distance variable. In this distance variable, this 1 is stored. And this v1 at the index of I dot second will give us this one. So total distance is 1 plus 1, 2, which is stored in our new distance. I hope now it is clear to you all. Now, if this new distance is the already present distance is TIST at the index of v1 at the index of I dot first. If this distance is greater than new distance, we are going to update its value and we are going to push it in our priority queue. After that, this loop will get completed and our distance array will get updated. Int maxi is equals to 0. What we need? Minimum time to reach to all nodes. Minimum time means maximum value present in our distance array. So that is why int maxi is equals to 0. We have iterated through the loop. If any of the index has the value 10 raised to the power 9, it means we cannot reach that particular node. And if we cannot reach that particular node, we need to return -1, what we did. And otherwise, we are going to find the maximum value and we will return the maximum value, which is the minimum time that is required to reach to all the nodes. I hope the question is clear to you all. If the question is clear, don't forget to subscribe to our channel and share it with your friends. Thank you.